accept the bin cell, and finally generate the state 0 with the string copy function. And launch the exploit. Let's see. Here, the vulnerable. Okay. So, exploit reliable, smoothly, no guess, no brute force. We will see how the difficult to bypass that on Fedora 13. Might take a while. Wow. Okay. Yeah. So you see here, stack address is 19 bits. Heap, shell library. So you see non-executable also. So with the default enable, we can have the exploit. Another exploit is the tip info. Here we have the use bin tip info. It will inject a BC and a proof of concept. We inject the BC program. And we see it in action. Actually, there is no string copy. So, string K compare, lost, string K compare, call. Okay, back to the last part. What is the countermeasure? So we see so far the best countermeasure for this technique or any return style technique is the position independent executable. With the position independent executable, every address are randomized, even the code of the program itself. So you cannot return to it because it's randomized. It's also add the 0 the null byte stack of address, so it will be hard if the ASCII armor enable or the null byte drop at the input. So far, the position independent executable is the most effective countermeasure to block return style exploits, but it's not widely adopted by vendor. You can see a lot of applications not compile with the PIE option because it requires the recompilation. And some application may impact with the performance penalty. So it's currently used in most critical application in popular distribution. In summary, so what we have seen here, generic, reliable, and practical return-oriented exploitation technique that can completely bypass on the system-level protection on modern Linux 32 bits can bypass and ASLR ASCII armor, and it does not rely or does not need the help from other information leak bug, and it can work on most of the binary. So buffer overflow now can be exploited. on Linux. And we have solved that the automated tool can be built to generate the ROP payload. It can be easy. So this technique, we did not research more on other operating systems, but I think that it can be extended for other operating systems like Windows, Mac OS, or BSD, because the x86 programming model is similar. Thank you for listening. I'm done. Thank you. Now, you have any question?
So, this whole technique relies firmly on the fact that your gadgets are at a known location. That's not randomized.
So you mean that this technique will rely on the binary location, no randomized? Yeah, exactly. With the binary combined without the PIE option. Yeah, that is the most popular on distribution. Yeah, exactly. With return style exploit, you need something static to return into. Thank you.
And you're releasing your Python script?
Yes, Python. Yeah. So.
Unless I'm way off base, it also required that your script be executed as an application that was residing on the machine. Impress it from outside.
Mm-hmm. So your question is how to attack from outside, not on the local machine. Yeah. In our demo, we run on the local, but actually we can generate the payload. No need to execute the vulnerable. We just generate the payload and send it to the remote host. All right. Yeah.
So you mentioned that to resolve the address limits functions in Libc, you assume that the offset between like system and strip copy is fixed. How does that work across versions of Libc? Is that reliable? The offset doesn't constant?
Exactly. With the return to Libc style exploit, it must rely on the Libc version.
Right.
Yeah. So if you have to generate the exploit for destination, so you have to know what Libc version. Okay. Yeah. You can pull the Libc from the remote host, put on your host, and generate the payload, and send to the host. Okay. Yeah. Thank you. Mm-hmm. I'm sorry, I cannot catch your question. Can you repeat it?
You're changing the data section of the executable.
Mm-hmm.
In particular, the DSS. So it's expected that a certain counter the syntax will go on to the executable. So is the executable flashing after you run it? So can you keep it running?
Actually, two keyboard I got it. So you mean that if we write to the data session or BSS session, it will make our the destination program crash after the exploit. Two keyboard first. If we exploit, we want to, for example, get a cell and forget the rest. It's okay. And if we want to return back to the function silently, so we have to carefully choose the address, we can pick any uninitialized, unused data area. It's available because the data is large enough for your shellcode. Yeah. Thank you.
This is strictly applicable to with using it with this definition of the 64
Yeah, interesting question. How about the 64-bit platform? The 64-bit platform, the idea can be applied except one. In the 64-bit platform, there are lots of null-byte in the address. So if our input drop at null-byte, forget it. If we can input the null-byte in the input, there another thing to be considered. That is the programming model on 64-bit is different. Its argument of function is not on the stack, but it loads into the register. So you have to find the gadget that load the argument address to the register. But it can be applied. I had a demo exploit for live-work proxy. It's something old in 2009, and it worked on the 64-bit. Thank you. Anyone else? Okay, thank you very much